and Assalamualaikum. Before anything else, let me introduce my group members. My name is Nur Akmal binti Ahmad Sukri, and the rest are Ahmad Aizuddin bin Muhammad, Mirza Qadrina binti Zamri, Anis Shahirah binti Ahmad. Nizam. Process Safety Accident Analysis of Chemical Industries is our case study title. So let's bring you guys to the discussion about this. About our project, many industries are built up around the world, but for our safety accident analysis that we only focus on 4 types of plant, which are refinery, petrochemical, upstream, and gas processing plant. At the total of accidents were studied, 20 of accident of each plant. For the general main hazard of accidents that we studied, which are explosion, fire, and toxic release. There are 4 types of main contributors that lead to the accident, such as organizational error, human error, technical error, and the last one is design error. All the accidents occurred may lead to the damage of equipment, environment, and affect the large scale of health and welfare employee. Furthermore, lack of understanding, information, or legislation also can contribute to the accident. The objective of these studies. First, to study the accidents in few types of chemical process industry within 1998 until 2018. For example, the study on the accidents occurred in petrochemical plant, gas processing plant, upstream plant, and refinery plant around the world within 1998 until 2018. Second, to identify type of hazard to be occurred. Chemical process hazard can be associated with consequent outcome of fire, explosion, toxic release, or combination of this hazard. Third, to identify the root cause. Root cause analysis is important in order to get to the underlying cause of the harm from the accidents occurred. There are different types of root cause, whether it is caused by human contributor or equipment contributor. If the root cause of an accident are not identified, only superficial solutions can be considered. Last but not least, for the objective, to rank the hazard. A priority ranking for each hazard of concern is assigned whether the hazard is in high risk, medium risk, or low risk.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza Qadrina binti Zamri. For this video, I will talk about the findings, which are including temperature involved in accident, NFPA value, and accident contributors. We go to the temperature involved. This graph shows the temperature involved in accident 1998 to 2018. As you can see, this is gas processing plant, refinery plant, petrochemical plant, and upstream plant. The temperature maximum is 2000 degrees Fahrenheit, which is belong to the refinery plant. The accident occurred in Washington State, USA on June 10, 1999. This accident occurred because of pressure relief valve failed and spilling 277,200 gallons of strong odors of gasoline when the gasoline vapor exploded. The temperature minimum is 10 degrees Fahrenheit, which belong to upstream plant, and accident occurred in Epcatan, Mexico 2015. The accident involved the fire hazard. We go to the NFPA of chemical. This is bar chart of NFPA of chemical in accidents 1998 to 2018. The total NFPA maximum is belong to ethylene oxide, which is 10. The head rating of the ethylene oxide is 3. Flammability 4. Reactivity 3. Accident happened in Ontario, California on 19 August 2004, where the explosion happened in ethylene oxide sterilization facility. Ethylene oxide explosive decomposition. The ethylene oxide decomposition occurs when the temperature at 932 degrees Fahrenheit. Ethylene oxide also presents an exposure hazard in addition to its high flammability, where it's rapidly or completely vaporized at atmospheric pressure and normal ambient temperature. Second, an FPA value belongs to sulfur, which is 2. The head rating of sulfur is 1, flammability 1, reactivity 0. The accident happened in Chevron Redmond on August 6, 2012, where the fire hazard occurred. Sulfur must be preheated before ignition can occur.
In this slide, show the percent of the accident contributor which are involved in organizational error, individual error, design equipment error, and technical equipment error. Based on 80 accidents that we are studying, 180 causes were found. The accident contributor technically oriented, including human error and equipment error. The most common causes was caused by human error, which accounts 93 causes. But for this equipment error, we'll divide to two aspects, which is design equipment error and technical equipment error. Causes from these two types of aspects belong to technical error, which accounts 49 causes or 27.22%. The example technical error involved in all accidents, which is safety devices or system, was failure or inadequate. The higher total on human error belong to organizational error, which accounts 49 causes or 27.22%.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aizudin. So based on the analysis of 80 accidents, the result shows that tank have higher possibility, which is around 21.51% to occur accident in chemical plant, followed by the piping, reactor work process vessel, and compared to the other equipments. Most companies follow the standards and the guidelines in the design, construction, and operation. But still, tank accidents still occur. This is probably because of the minor mistake action that lead to a major accident in the tank, such as tiny holes that could lead to a liquid leaking from the tank. Some company also does not follow the regulation from the local safety institution, especially during inspection and maintenance work. So, these companies ignore this command because they know that the safety regulation during maintenance works or operation will cost them a lot. Although they have made so much profit from the production, they still do not want to spend their money to repair or fix the broken part in the tank. Oxidizer, storage, conveyor, raffinate, splitter, fractionator, pump, compressor, and chamber share the least possibility equipment to occur incident in chemical plant. This is probably because this equipment is not really a major and a big equipment in chemical plant, so the operator can easily check the efficiency and do the maintenance work for this equipment. There are lots of processes happen in chemical plant. Most of the accident that happen in chemical plant is when the chemical substance is being handled off or in processing. And mixing process is the most recorded process that happen during accident in chemical plant, which is around 13.58%, followed by ignition 11.11%, and transportation 8.64% compared to the other processes. This is probably because of the incautious of the operator during controlling the following liquid, so the liquid mixed with the wrong substance or wrongly connect a pipe and cause an accident in the plant. So most of the accident would have been avoided if good engineering have been practiced, such as good labeling, and operators should be more alert about what is going on in the plant. Explosion is the most hazard that involved in accident in chemical plant, which is around 40% compared to the other hazard, followed by the fire, toxic release, and blowout. There are three main elements that combine to create a plant explosion, which is heat, the creation of gas, and a dangerous reaction. In order for an explosion to occur, chemicals must generate a large amount of gas within a short amount of time. Often, the chemicals involved in an explosion will become explosive when they come into contact with the oxygen in the air. When chemicals produce large amounts of gas in a short time frame, even those that are not generally explosive can generate an explosion. Heat and dangerous reaction are the cause of many plant explosions. Gas leaks, most often caused by the poor maintenance, result in a number of explosions. Each year, when a gas leak comes into contact with a source of heat, they begin to expand and can explode. Sometimes, plant explosions are caused by the use of impure chemicals. Impure chemicals can produce large amounts of gas, which can trigger a dangerous reaction and ensuing explosion. Most of the accidents happen in chemical plants is because of the overpressure in the equipment that lead to explosion or toxic release. The operator should be more alert about the condition of the chemical composition, especially the pressure. Because pressure is very fragile to handle, they can easily go ups and down within a second. And every little change in pressure would cause a different product. The most highly pressure is recorded in gas processing plant, which is around 30,000 psig, followed by the upstream 18,000 psig, and petrochemical 2,000 psig, and the refinery around 1,300 psig.
For the conclusion, routine safety precautions are key. Most of the accidents were caused by negligence. Ensure safety working procedure and measures are in place and must be proactive and vigilant to avoid the reoccurrence of the accident. Okay, so this research performed an analysis on a catastrophic hazardous chemical accident involving a domino effect, focusing mainly on its process condition, consequent causes, and accident contributor. This research gives a good lesson, such as it gives the knowledge about the process safety accident analysis. So, the study of previous accident is an efficient way of learning lessons to prevent similar circumstances from occurring in the future. So, there are a few chemical safety legislation in Malaysia. First is use and standard of exposure of chemical hazards to health. Okay, the function is to register and control of chemical hazards to health, so that the chemical are kept at the workplace safely. Second is classification, labeling, and safety data sheet of hazardous chemical. Regulation 2015. Okay, the function is to inform management system about the hazardous chemical. Okay, third is control of major industrial hazard. Regulation 1996. Okay, the function is to prevent of major chemical accident. Okay, last is notification of accident, dangerous occurrence, occupational poisoning, and disease. Regulation 2004. The function is to notify chemical accident. Okay, for recommendation. First, in industry, manufacturers should be proactive in order to evaluate potentially products dangerous. In order to determine safe storage condition, monitoring for real condition and elevated temperatures during storage should be carried out. Second is hazardous chemical storage facilities should establish standard operating procedures for storing and handling material that resolve storage restriction. Okay, last is installation that store, use, treat, produce, or transport hazardous material should create and enforce a system to assess the possible hazards of changes to installation, facilities, chemical technologies, or processes.